In this video, we're going to cover logarithmic differentiation. So logarithmic differentiation is a method of taking the derivative. We're pretty much using log to help us differentiate. The reason why we use log is because log has like few properties that could like turn these complicated functions into simpler ones. Before we begin any problems, let's review the properties of log. So we have the power rule. So when we have log of a times b, this is simply just log a plus log b. And then there's the quotient rule. So we have log of a divided by log b, which is simply log a minus log b. And then we have the power rule. So when we have log a raised to the power of b, this is simply just b times log a. The property of log lets you bring down the exponent to the front. This is why like logarithmic differentiation is very useful, because if we're dealing with like a power function or like a big quotient function, a product function, then this will help us make things easier. So let's start off with the basic one. So we have x raised to the power of x. So how can we find the derivative of this? Well, what we gotta do is we first have to make y is equal to x raised to the power of x. Then what we'll do is take the natural log on both sides. And the property of log lets us bring the exponent to the front. So we have ln y is equal to x times ln x. Now our next step is to take the derivative on both sides. So the derivative of ln y is 1 over y times dy dx, which is equal to, and then for this one we have two product here, so we just need to use the product rule for this. So f of f prime g plus g prime times f. So the derivative of x is just 1. So 1 times, and then ln x plus the derivative of ln x is 1 over x. And then we just put x here. So these cancels out. So we simply just have ln x plus 1. And then on the other side we have 1 over y times dy dx. Now our next step is to isolate for dy dx. So I'm going to like solve for dy dx by like moving the y to the other side. So I'll multiply by y here, multiply by y here. So this will be dy dx is equal to y times ln x plus 1. And then earlier we said that y is equal to x raised to the power of x. This means dy dx is equal to x raised to the power of x times ln x plus 1. So that's the derivative of x raised to the power of x. So the steps of logarithmic differentiation is just setting it to y equals a function, and then taking the log on both sides, then take the derivative on both sides, and then isolate for dy dx. That's the steps. Now try this for yourself. So y is equal to x plus 3 raised to the power of x plus 2. Try that. Find the derivative of this function and feel free to pause the video. Okay, so the first step will be taking the log on both sides. So ln y is equal to ln of x plus 3 raised to the power of x plus 2. And the property of log lets you bring the exponent to the front. So ln y is equal to x plus 2 times ln of x plus 3. Now our next step is to take the derivative on both sides. So the derivative of ln y is 1 over y times dy dx, which is equal to, and now we need to take the derivative of this side. So the derivative, we need to use the product rule. So f prime times g plus g prime times f. So the derivative of x plus 2 is simply just 1 times ln of x plus 3 plus the derivative of ln x plus 3. So the derivative of ln u, so u is a function, is simply just u prime over u. That's the derivative of a natural log function. So u prime, this thing inside there. So the derivative of x plus 3 is just 1. So 1 over, and then x plus 3. Then we multiply by x plus 2. Now we can just simplify this. So ln of x plus 3 plus x plus 2 over x plus 3, which is equal to 1 over y plus dy dx. And now we need to isolate for dy dx. And by the way, I just meant multiplication. So dy dx is equal to, so y, we're just multiplying y by both sides, so these y cancels, and then I multiply here, so ln of x plus 3 plus x plus 2 over x plus 3. That's the derivative. I need more space, so I'm just gonna erase this part. So our final answer, dy dx, is equal to x plus 3 raised to the power of x plus 2 times ln of x plus 3 plus x plus 2 over x plus 3. That's the derivative of this function right there. We can use logarithmic differentiation not just for like power and exponent. We can use it on like quotient and product. So let's try this for example. So y is equal to x squared plus 3 raised to the power of 4 all over 5x minus 7 raised to the power of 6. So this is massive. And if I try to use the quotient rule like the original way, I will have a hard time because there's no way I'm going to square the bottom part. So I'll stick to logarithmic differentiation. So I'm going to take the log on both sides. So I have ln y. And then for this one, if I take a log on this, earlier I said that like the property of log for quotient is simply just log a minus log b. So we'll apply this here. So this will be ln of x squared plus 3 raised to the power of 4 minus ln of 5x minus 7 raised to the power of 6. And I can further simplify it, so I'll bring the exponent down. So we have ln y is equal to 4 times ln of x squared plus 3 minus 6 times ln of 5x minus 7. Now we have to take the derivative on both sides. So ln y, the derivative is 1 over y times dy dx. The derivative of this thing here, we just simply take the derivative of each of them. So the derivative of this one here, so as I said earlier, ln u, the derivative is just going to be u prime over u. That's the so in this case our u is here. So in this case, this is the u, the inside function. So the derivative of that is simply, so x squared, so minus 1, bring down the 2, so it's just 2x. That's the derivative of x squared. So we'll apply it here. The derivative of x squared plus 3 is just 2x, since that's a constant, all over x squared plus 3. And then we multiply by 4. Subtract 6 times, so the derivative of 5x minus 7, the derivative of 5x is just 5, and the derivative of 7 is just 0, so we do not need that. And then on the bottom is just 5x minus 7. That's the derivative. And now we isolate for dy dx. So I'm going to multiply by y, so these cancels out, and I'll multiply by y here. So therefore this leaves us dy dx is equal to, and earlier we said that y is equal to this whole thing over there, so it's going to be x squared plus 3 over 5x minus 6, and then I'll put the exponent 6, 4, and then multiply by this thing on top here. So 4 times 2x, I'm just gonna say it's 8x. 8x over x squared plus 3 minus 30 over 5x minus 7. So that's the derivative of this function. Also, I take that back with my answer. This bottom here is supposed to be 5x minus 7. I just made a little mistake there. So this is now the final answer. That's the derivative. And by the way, if you're wondering why I didn't bring down the exponent with log right there, it's because I have an addition over here, and there's no property of log for addition or subtraction, so you can't really break down anything there. That's why. But however, if you had an exponent or a multiplication or a division, then you could use the property, but here we can't. Now try this for yourself. So we have y equals x squared plus 1 raised to the power of 5 times 3x minus 2 to the power of 7 times x to the power of 3 plus 4x raised to the power of 10. This might look crazy, but it's actually simple. So go ahead and pause the video and try it. So our first step is to take the log on both sides. So ln y is equal to ln of, I'll put a big bracket here, so ln of x squared plus 1 raised to the power of 5 times 3x minus 2 raised to the power of 7 times x to the power of 3 plus 4x raised to the power of 10. And now, because we have multiplication here, we can just break them up into addition from the property of log. So ln y is equal to ln of x squared plus 1 raised to the power of 5 plus ln of 3x minus 2 raised to the power of 7 plus ln of x cubed plus 4x raised to the power of 10. Now we'll bring down the exponent on each of them because that's the property of log. So ln y is equal to 5 times ln of x squared plus 1 plus 7 times ln of 3x minus 2 plus 10 times ln of x cubed plus 4x. Now what our next step is to take the derivative on both sides. So d over dx of this whole thing, and if I take the derivative of this, that's gonna be 1 over y times dy dx. And by the way, make sure when you're showing your step, write the d over dx. I just didn't have enough space, that's why, but I recommend that you should write it because your teacher might take off marks. Now, because we have like an addition here, we can just take the derivative on each of those. And the derivative of ln u is u prime over u. So in this case, this is our u. The inside function is the u. So the derivative of x squared is 2x, and the derivative of 1 is just 0. So, and then I'll multiply by 5 because that was on the top, and then x squared plus 1, that's u, plus 7 times the derivative of 3x is just 3, and the derivative of negative 2 is 0. And then on the bottom it's just 3x minus 2 because that's the u, and the top one was the u prime, plus 10 times, so the derivative of x cubed using the power will be subtract 1, bring down the exponent, so this is just 3x squared. So we have 3x squared times the derivative of 4x is just 4, and then on the bottom it's simply just x cubed plus 4x. So this is the derivative of this whole thing over here. Now we need to isolate for dy dx. So I'm going to multiply by y, and then multiply here by y. So the y variable cancels out here. And now dy dx, our final answer is equal to x squared plus 1 raised to the power of 5 times 3x minus 2 raised to the power of 7 times x cubed plus 4x raised to the power of 10, and then multiply by this whole thing over here, which is 10, so 5 times 2x is just 10x, and then over x squared plus 1 plus, so 7 times 3 is 21, so 21 over 3x minus 2 plus, so 10 times 4 is just 40, and then 40 times 3x squared is 120x squared, all over x cubed plus 4x. Now this is our final answer. Look how much easier logarithmic differentiation made. Because if we had used the product rule, it would have been a nightmare. And by the way, this is supposed to be a plus, my bad. So this means that it's just 10 times 3x squared plus 4. This is the final answer. let's say y is equal to x to the power 4 plus 1 times square root of x plus 2 all over 2x squared plus 2x plus 1. This time you have a both like a product and like a quotient. Let's begin by taking the log on both sides. So ln y is equal to ln of this big equation x to the power of 4 plus 1 times x plus 2 all over 2x squared plus 2x plus 1. And now we need to use the properties of log to like break this apart. So ln y is equal to ln of x raised to the power 4 plus 1 plus ln of square root of x plus 2 minus ln of 2x squared plus 2x plus 1. Now our next step is to take the derivative of both sides. So d over dx here, d over dx. So the derivative of ln y is 1 over y times dy dx, which is equal to, so the derivative of this function here, the derivative of ln u is equal to u prime over u. So we have a u that's inside here. So x raised to the power of 4, using the power rule, we subtract 1 and bring down the 4. So then we have 4x cubed. This is the derivative of x to the power of 4. And the derivative of a constant, which is 1, is 0. So here we have 4x cubed over 4x to the power of 4 plus 1 plus, and the square root function here, we can use the chain rules to find the derivative here. So this is pretty much x plus 2 raised to the power of 1/2. So we need to use the chain rule for this. So we need to find the derivative of the inside function and the derivative of this whole thing, the outside. So we'll first find the derivative of the outside. So we can just use the power rule for that. So subtract 1 and then multiply by 1/2. And then we multiply by the inside function, which is just 1 because the derivative of x is just x. It's 1. So square root of x plus 2, and then we have on the top we have x plus 2, and then to the power of negative 1/2. Subtract. So the derivative of this function, so the derivative of 2x squared, so subtract 1, bring the 2, so we have 4x. This is the derivative of 2x squared. So it's just 4x plus the derivative of 2x is just 2, and the derivative of 1 is 0. And on the bottom, it's the same. So 2x squared plus 2x plus 1. That's the derivative of this whole thing. Now we need to isolate for dy dx, so I'll multiply by y. So these two cancels. Multiply by y. So dy dx is equal to, so earlier we said that y is equal to this thing. So x raised to the power 4 plus 1 square root of x plus 2 over 2x squared plus 2x plus 1 times 4x squared over x to the power 4 plus 1 plus, and because this is raised to a negative power, we can simply just bring this down. So it's going to be on the bottom, we're pretty much multiplying by square root of x plus 2 times square root of x plus 2. On top is just 1/2, and when you're dividing, you can basically bring the 2 down. So it's going to be basically x plus 2 because the radicals will cancel out. So it's going to be x plus 2 times 2. That's what this gives. And if we expand it, we get 2x plus 4. 1 over 2x plus 4 minus 4x plus 2 over 2x squared plus 2x plus 1. So this is the derivative of this function. Let's try one last example. So cosecant x raised to the power of sine x. Let's find the derivative of that. So y equals cosecant x raised to the power of sine x. We take the natural log on both sides. So we have ln y is equal to, with the property of log, we can bring down the exponent to the front. So we have sine x times natural log of cosecant x. And now our next step here is to take the derivative of both sides. So y is 1 over y times dy dx, which is equal to, and now here we need to use the product rule. So let this be f and let this be g. So the product rule is f prime times g plus g prime times f. The prime kind of look bad, so here. The derivative of sine x is cosine x, and then multiply by ln of cosecant x plus, and now the derivative of this, the derivative of ln u is u prime over u. The derivative of cosecant x is negative cosecant x cotangent x over cosecant x. So we can cancel this out and we have cotangent left, negative cotangent x. So this is what we'll put here. And since it's a negative cotangent x, I'll put it like this. Negative cotangent x times sine x. We'll multiply by y on both sides, y on both sides. So the y variable cancels here. So now we have dy dx is equal to, and earlier we said that y is equal to this thing over there. So we'll replace y with cosecant x raised to sine x. So cosecant x raised to sine x times, and then this whole thing inside. So cosine x times ln of cosecant x minus cotangent x sine x. So this is the derivative of cosecant x raised to sine x. And thank you for watching. Please subscribe to my channel for more videos. And as always, see ya. Bye.